Hello, I'm Dan Davis with Fabricator Magazine. Welcome to today's webinar, Lights Out Machining, sponsored by Biesse. Today's presenter is Jim Fields, someone who has decades of technical experience in advanced cutting systems. Today, he'll share some practical insights in waterjet cutting technology, smart automation, and predictive maintenance. He's a strong advocate for lights out manufacturing and continuous process innovation, and he partners with manufacturers all across North America to drive productivity gains and maximize ROI. So I'm going to hand it over to Jim. If you have any questions, please use the question function and we'll answer those at the end of the webinar. Thank you for attending. Jim, take it away.
Hello, everybody. Thank you for attending, as Dan just said. And Dan, thank you for the kind words. Thank you to FMA for our hosts at FMA for facilitating this. I know the audience's time is valuable, so I'm going to try to be concise in every one of my points and kind of move forward with this to hopefully you gather some good information out of this presentation, probably about 35, 40 minutes at the most. But today I want to illustrate technology that allows for unmanned operation and real-time feedback that leads to faster cycle times, fewer rejects, lower energy and abrasive usage, ultimately reducing downtime and increasing profits. We're all big fans of that. So, Dan, thank you. I mean, the introduction was very kind, but I mean, I've been in manufacturing. I'm going to add a little bit more about me, just because I love talking about me, but that's beside the point. I started in fabrication, manufacturing as a toolmaker apprentice back in 1981. I graduated in 93. So I've been around manufacturing since that time, dating myself a little bit, but that's okay. And got into waterjet early on, and early like 93 is when I joined into the waterjet field. And I've been in all phases of waterjet since that time. It's so much fun. I've enjoyed it from the standpoint of the application, what people can do with it, things like that. Up till about 2009, and I started my own fab shop. I thought, well, this looks easy, right? Everybody can do this. So I had a waterjet and started cutting my own parts, did a lot of signage down in the Dallas area. This is important because this is the first time I actually started caring about the bottom line and how many inefficiencies there are in manufacturing, right? So whether it's in waterjet or plasma cutting or machine work, there's so many inefficiencies, and it's not a flood of water, meaning water being the money, going out of your business. It's a colander of money going out your business. So all these little holes where we leak money at the end of the day, and we say, okay, well, as a shop owner, it was kind of like, okay, I bid this job strong enough. Where did we lose the money at the end of it? We did it how we were supposed to, but then there was downtime and there was different maintenance issues and people issues and all these different things that added to losing money. So I became a little bit more passionate, and that's kind of where that all started. Is, you know, once you have a bottom line responsibility, it's a little bit different than the worries we have at the top line. So enough about that. We're going to move on. What I'm going to cover, I'm going to get into a little bit about BSA, who we are as a company, and how TEKNI came to be part of BSA. So anybody that may know me from the industry knows me from TEKNI Waterjet. Before that, I was with Flow. I mean, there's a lot of different segments of my career, but I've been with TEKNI Waterjet for the last 13 years, something like that. And then now joining BSA in 24. It's an exciting new chapter for some things that we just didn't have. But anyway, I'll dig into that a little bit more. But who's BSA? Who's TEKNI within BSA? Optimize cutting performance, minimize downtime with predictive maintenance. So this is very important to the value proposition that we're putting forth here. And then advanced diagnostics for smarter operation. It removes the guesswork for the pump and the high pressure where we generate the water pressure. This is critical to making money at the end of the day. The water jet industry has been very subjective over the years, so people relies on the operator to tell you and give you that feedback. TEKNI reinvented what that looks like, and we're going to dig into some of that stuff. So TWJ has been on a constant growth journey since entering the U.S. market. Founded in 1989, we expanded into the U.S. in 2005. So we were a little late to the game in the U.S. The 2005 it was pretty mature, but we were still on a steady growth path. And then joined the GMM group in 2018. If there are any customers on here, they would have gone through that with us likely. And in 2024, when Biesse acquired the GMM group, we became part of the Biesse family. And it really is a family of people that are really high quality, high achieving individuals that want to do really well for our customer base. And that's really important to me. So Biesse focuses on advanced technologies, just like we're talking about today, and delivering exceptional customer care. And that aligns with our vision, right? The vision that we had prior to. Their deep commitment to customer experience creates the ideal environment for TWJ to reach the next level of maturity and success. This is a very good partnership. I just want you to know that coming across from my heart to your information is the marriage here is going to take us to the next level. So moving on, I have my little introduction slides. So who's Biesse? Biesse, simply put, is manufactures lines, machines, components for making products, enhancing the potential of the wide range of materials processed by our customers. So you're going to hear multi-materiality a lot through this. They address basically manufacturing and tools for manufacturing to address our customers' needs by material, which some of those cross over, some of those don't, but we are specific to those particular needs. So we simplify the product production process of customers working in the furniture, construction, automotive, aerospace, general fabricators, and machine shops now. So that's a powerful statement, right? We simplify the production of processes. So you'll see that throughout our whole product line. So Biesse was founded in Pesaro, Italy in 1969 and listed on the Italian Stock Exchange in 2001. And we're driven by our international calling, which is manifested through global network of showrooms where customers can enjoy a multi-material experience. I'm overlooking the showroom here in Charlotte. It's a absolutely spectacular place, and we'll speak to that a little bit more, but we certainly invite you to come and visit us here. Speaking to multi-materiality, what does that mean? To me, it means flexibility. We're a one-stop provider of technology and machine equipment to make your business smoother operating, more efficient itself, and to grow your profits, right? So by doing this Biesse, kind of the Biesse architecture, it's got kind of this simple, the same control philosophy and service model across all materials. So basically it equals, shared spares, shared training, and one support spine that runs through all of our different divisions, our different materials for our customers. Makes us very powerful in that support structure, I should say. If you look at kind of Biesse as the master brand, the company's value to the markets through one company approach. Biesse is the master brand. Our brand architecture presents in a clear way our full portfolio in 3 segments. So this is the point of this slide. 3 segments is the lines, the machines, and components. So TEKNI, I don't know how to say it. There's too many tech type of companies in the portfolio, is our lines business basically. So would be a whole factory line. So multi-processing that'll material starts on one end and finishes at the other end. So that may have multi-processes within it. And then you've got the machinery division, which has basically got something for everyone in every material. So again, you got your wood, you got your stone, now we got the metal and all the different materials, glass, it's a full complete portfolio. And that rounds out with, Biesse, GMM, TEKNI, and Bavoloni type machines. Then on the tooling side, we get here, you can see the HSD and the Dimute and the Bavoloni tools. Those are all complementary tools, tool divisions for us, and highly highly reputable companies that actually fill out the customer care part by being a tool supplier for them as well. So I hope that's clear and gives you a little bit more idea. Biesse machine is brand machinery. It's brand dedicated to the design and production of technologies for processing. I'm gonna stop saying that this light issue was a known issue. Processing wood, glass, stone, plastic, composite, and metal. So I'm probably going to stop saying the different materials because we all know what those are, but I think it's important to understand that we do work from those materials back. And each one of those materials, we have experts within the family that know each one of those materials intimately as to how to process it best and be really efficient in doing so. So our solutions are designed to support the evolution of industrial processes, simplify production, and increase customers' operational efficiency. That's us in a nutshell. I'm here on the Biesse campus. The Biesse campus, located here in Charlotte, is 77,000 square feet under one roof, or under multiple roofs, actually, so 5 different buildings. I'm here in the 23,000 square foot showroom and training facility. As I said earlier, it's a spectacular kind of deal. Gene, maybe I will have you come up here and walk around because of this light. With TWJ now being part of BSA, the strategic integration strengthens our capabilities in the metal sector and enhances our ability to deliver complete solutions across multi-materials. Our customers are welcome year-round for on-site demos, and I hope that this just gives you a little bit of this is just a scratching the surface of who BSA is globally. Please visit our websites and any of our subdivisions or any of our divisions websites as well for more detail after the presentation. I don't want to spend too much time there. We want to get into the meat of this, which is optimize cutting performance. So what does that entail? Controlling the pump technology, the pressure control, abrasive required, and impact of pressure on the dose. Like how much dose is required as the pressure rises. So the garnet consumption goes down as we raise in pressure. Going to get into a lot more detail about that. But ultimately, this first aspect of it is the ultimate operating efficiency. That's what we're after. What's the ideal setup before we can start using some of the other tools that we have at our disposal. So traditional technology has been the hydraulic intensifier and the triplex pump technology. These have been traditional technologies until quantum pumps, patented the servo pump technology, which I'm going to speak about. What we liked about intensifiers is they're capable of delivering a very high operating pressure. That's a good thing, right? So more pressure, faster cutting, more efficient use of the garnet. The con on a hydraulic intensifier is deadheading without power reduction results in unwanted pressure spikes that cause reduction in high pressure components, longevity, right? So the higher the magnitude of the spike, the pressure spike, the quicker the metal fails. Certainly more details on that if anybody's interested. Typically, it's very inefficient. Energy in does not equal energy out. So they take up more space. They're noisier than direct drive and servo technologies. So that's an important differentiator when you're looking at hydraulic intensifiers or even just trying to understand it. When you get into the direct drive technology, that's the triplex here. That's three cylinders, 3 pistons, 3 plungers, whatever. So now we're running at 1400 RPM to do what we do, a hydraulic intensifier does, and what we do at about 80 strokes a minute, right? So 1400 RPM, quite aggressive, builds up more heat. The pro is that it's smaller, quieter, more efficient than intensifiers, right? Problem with it is you cannot deadhead and must dump the water over a relief valve to drain whenever the pump is on. So when the pump is on and I'm cutting a typical sheet of metal, I'm going to have many on-off cycles. So the direct drives become inefficient when I start going through these on-off cycles, right? So whenever that nozzle closes on the direct drive, they have to reroute the water somewhere else. So the other thing that I think is a downside for a triplex, the running faster, that's more wear, more heat generated. but you also have a third cylinder just out of the box. So initially you have more components in maintaining your pump. So what TEKNI did, Quantum did, I should say, is we said there's got to be a better way. So it initially what we had designed was the PAC, right? So the PAC is precision angle control. What precision angle control, which is 5-axis cutting, and taper compensation and this type of thing, right? The secret is what we did was we were the first to come up with 2 independent motors inside a housing, right? So now I'm able to have a motor and a motor, and then a hollow shaft that goes through it. So one rotor is hollow, allowing the shaft of the second motor to pass straight through it. At the bottom, those 2 shafts drive the B and the C axis right here. This hollow rotor design sparked an idea. So we said, okay, what if we, oh, excuse me, little click happy. So what if we turn this on the horizontal, which is what we did, right? So then obviously it's got to be more robust. So excuse me. So all we need to do is reciprocate the motion. So basically we took it from being 2 axes of motion here, which are rotary kind of motions. We took it to a reciprocating motion that was fairly simple to in concept, but hard in reality. So the engineering, the time and the discovery that went through supersizing this for these ultra high pressure applications was quite an undertaking. So, but what we were able to do is attach the ball screw to the rotor and letting it travel through the hollow center. We created a completely new way to drive a high pressure pump. So with servo control. So what this is it's basically taking the best of both worlds. I'm going to go to the next slide. So basically that was the birth of the electric servo pump, right? So what we did is we built a pump that's more efficient, quiet, compact, and capable of delivering very high pressures while being easy to maintain. This is very significant in the industry, and it really was a game changer. It's a patented technology, so you don't see it on all systems, and that's why it's kind of unique to us. But the real magic is in the constant pressure. The linear actuators are infinitely controllable, adjusting in real time to hold pressure steady. I'm going to explain a little bit more of that because that doesn't mean a lot just to how it's read. That gives us longer life of high pressure components, smoother edges on cuts, and less garnet usage. That less garnet usage is very key to what we're laying out here. So in other words, better quality, longer life, and lower costs. So what does that look like? We need to talk a little bit first about deadheading and why this is so important. With the 2 previous technologies that I'm talking about, deadheading is when your jet's off, right? So then that ultra high pressure has to be available when that jet comes back on. So with hydraulic intensifiers, they need to continue to run the motor in order to cool the oil through the heat exchanger. So with direct drives, what you have to do is you have to reroute that water, right? So when the cutting head is closed, so deadheading as defined is intervals during the cutting process when the cutting head is closed and the pump is still running, right? So the pump's still running, but it's not going through the nozzle. So we have to reroute that, and they both continue to use and consume power and water. So with intensifiers and direct drives, the motor keeps running full time, even during deadheading. Intensifiers waste about 60% of their power in this mode, and direct drives waste nearly 90%. That, again, depends on your on-off cycles frequency, right? So the servo pump works differently. As soon as the head closes, so as soon as that jet goes off, the motor and all auxiliary equipment or circuits shut off. When the head opens, everything restarts instantly. That's why during deadheading, our pump uses only 3% of the power, which is a huge savings in the energy and cost of operation. So again, I can go jet off, my system stays under pressure, but there's no motion anywhere in it. Components last longer. There's less heat generated. There's a number of favorable effects that for the end user, you benefit from longer life of components and this type of thing. So moving along, best of both worlds. So for intensifiers, we wanted to keep some of these things that we liked, right? There's things we liked about both of these technologies, and we said, we want that in our pump. So hyper pressure was one of them. So we wanted the ability to go to these high pressures where we really get into some of these efficiencies. We wanted the stable pressure, we wanted the stable pressure signal that's not really driven with spikes. We wanted the durability. We wanted the durability that a hydraulic intensifier brings. It's a robust type pump. So we wanted that to be built into our system, and we did. For direct drives, we wanted the simplicity. It's a very simple pump to run, and it's simple in concept. It's like a motor in your car or half the motor. And we wanted responsiveness, right? Responsiveness was what we liked about that. Water is ready straight away. And then we kept in efficiency while the pump is running. I want to be clear on that. So direct drives are very efficient when the jet is on. When you start adding on-off cycles into it, they rapidly become inefficient. So it's important to understand that. Deadheading bad, jet running good. So in the end, the electric servo pump combines the very best of intensifiers and direct drives while eliminating the biggest drawbacks. It's powerful, precise, durable, highly efficient, and it's built on a patented technology. So that's a good thing. Moving along, this is a very important kind of cost breakdown, and I think most people, if you're familiar with Waterjet, you're familiar with some of this. But by mastering the abrasive pump power, and we control 85% of the operating costs. So you've got here the abrasive usage, 50% of your operating cost. 25% is the pump, seals, that kind of thing. Then you get into the cutting head. Those are consumables, so that's going to be pretty standard throughout, and you can't really do much about that. And then 8% is the power. We can reduce the power, so that's a significant number. So if you go, this 75% we can control, and this 8%, so we get close to that 85% by controlling abrasive dosage and consumption, pump design and efficiency, and power consumption. All of those are very, very easily and consistently and fully controlled by the servo electric servo pump. So this is very important. Control these three, and you control the P&L of your water jet. Very, very important, because this is real money that's going out. And I think that's the part where most people can miss their targets when they say, okay, I'm going to bid this job at X, and then they come in behind, they come in at Y, and they lose money. And they lose money because of this graph here in these areas. They're either running too much garnet, they're using too much power, whatever the case that they did not necessarily account for. So this is the kind of a breakdown of what that looks like. So low cutting speed compared to high cutting speed. So low pressure requires more garnet. So there's more garnet to do the same work, and costs per inch goes up. So as I'm using garnet, that's 50% of that operating cost, that my cost per inch goes up. Higher pressure requires less abrasive while piercing quicker and cutting faster. So that's a good thing. So now I'm using less of that 50%, and I'm able to cut faster. So machine time, slower cutting speed reduces throughput. High pressure, aka faster cutting, frees up more time for the day to cut more jobs. So if I just cut more on my water jet during the day, I have more billable hours. This is a good thing, right? Operating cost, lower the pressure equals higher cost over the same period of time, as more garnet is consumed for the same amount of output. So if I got to cut the same part, I'm going to use that much more garnet to cut that part, because I'm going to cut it quicker at high pressure, slower at low pressure, and I'm going to have that additional garnet consumption. Very important to understand that. High pressure equals low cost due to less garnet, energy savings, and higher output utilization. So I'm going to get more parts off my machine per day at the higher pressure and the lower use of garnet. And that's kind of how we build up our efficiency model. So we did just a comparison here. We kind of locked everything in. The project settings were locked in at 1/2 inch steel. Cut quality was medium fine, which would be a 60%, 7 pounds per minute. So this is all set within both of these comparisons. And then we're running 90% of max pressure. So you don't ever want to run your pump at 100%. So these particular scenarios will run at 90%. So on the 66,000 PSI setup, for this setup up here, we basically had a 1230, more water, 1230 is the orifice sizes. So over here, we were able to go with an 11 thousandths orifice. Sorry, excuse my mouse. 11 thousandths orifice here, and the same amount of garnet per minute. However, garnet per inch goes down to 0.11. So if you look at the inches per minute that goes up for cutting speed, it's a 46% increase. That's enormous in profitability and output and this kind of thing. Then you look at the abrasive consumption, it goes down. The takeaway is over here, right? Basically, we are cutting at the lower pressure, more garnet. We're cutting with a slower inches per minute, 4.3 inches per minute. Here, we're using 0.16 pounds a minute per inch. And then down here at the higher pressure, less garnet, we're cutting at 6.3 inches per minute, a 46% gain, which is the takeaway of this slide. And abrasive is 0.11, which is a 32% reduction in garnet usage. Again, if you look at that being 50% of your operating costs, this is a significant savings to the end user. Okay, everybody clear on that? So let's kind of move on to some of the next things. So, you know, that's the foundation of optimal machine pressure and cutting head parameters. So let's move into kind of what do we do with that? You know, now we're doing more things. So now we want to minimize our downtime. So optimizing, let me say this, optimizing the cut is what we just talked about. Water pressure, garnet flow, these different parameters. We lock those in, and that's what gives us the optimal tool. Now, you know, what's the next avenue that we want to address? It's the minimizing the downtime. And what does that mean to every shop with all the processes that are out there? So the biggest downtime for most water jets is either load and unload, but it becomes maintenance side of things, right? So there's three different approaches to maintenance. There are the reactive. Typically, a hydraulic intensifier will run the components to failure, right? So a check valve, sealing head, whatever, or a high pressure seal, or whatever the case is, they'll run it to failure, and they'll just keep an eye on it. There's no real feedback from it. It's just the operator goes and touches it. It's very subjective. The operator touches it, says it's hot. How hot? Hotter than yesterday. Okay, keep an eye on it. So they don't end up working on it. It's like I said, reactive maintenance. They don't end up working on it till it's spraying water. So these have safety weep holes, and they'll be spraying water once that sealing surface has completely become unusable, right? And then maintenance is required. Well, I might be in the middle of the hottest job I've had in a month, right? So you don't want to be reactive. You want to be able to understand what's going on with your pump, with your machine at all times, and you want to be able to do predictive maintenance. The other hand, the direct drives, they can't run to failure because they're 1400 RPM is how fast they run. So at 1400 RPM, you've got more heat that's generated, more wear that's generated. You got a third cylinder, so they can't run to failure because you're going to cause something more catastrophic to happen. So what you do with the direct drives is you do what's very traditionally called a PM, a preventative maintenance. So preventative maintenance, what inevitably happens is we do maintenance, we replace components before their end of life. I don't think that's a good thing, right? That becomes kind of almost like a wasteful thing. So at the end of the day, predictive maintenance is what TEKNI said, this is the better thing. Now we've got this servo pump with all these electronics. We can actually monitor stroke rate, the draw on the current draw, temperatures, pressures, all of these components that give you a look inside the pump. So that's very unique to us, and it's such a valuable tool. So part of predictive maintenance, how do we do it? That's what I want to get into in this next section, which is TechSense, TechConnect, and advanced diagnostics. That's the meat of how we do it. So jet set up to be optimum performance and efficient. Now we have predictive maintenance, so I can schedule that same seal change. I could schedule tomorrow morning after work today. I don't have to stop the job that I'm running. So we'll get into some of those now. Pardon me. Let me get back to, here we go. Okay, so predictive maintenance starts with TechSense. So TechSense basically is monitoring. It's a vacuum sensor on the feed line. So we're monitoring what's going on at the cutting head. The cutting head has your orifice, your focus tube, and it's got your garnet flowing through it, right? So any three of those going outside of a certain set bandwidth will cause a shutdown, right? So or cause a bad cut on other systems. So what happens with our TechSense is we're able to get that message when that Venturi changes, gives us information about what's going on. If it's catastrophic, say I lose garnet flow, it immediately puts it into a soft feed hold, shuts it down, tells the operator something happened with the garnet. So this is significant. So we're talking about some things on the pump, we're talking about the setup of the machine, and then now we're talking about what's going on at the cutting head and how do we address that. So that feedback is valuable to us closing, excuse me, it's a valuable piece of closing the loop on unmanned operations. So in order to be unmanned, we have to make sure everything is giving us feedback that could cause a problem to the part that's being cut or to the machine itself, causing further damage. So that's kind of what we're trying to get across here. So predictive maintenance, what we monitor is we basically put high tech sensors on the oil, the water, the air circuit, and communicate directly with the pump. So we're always knowing what's going on with the dump valve, where you know what's going on, what's the temperature on the check valve, right? So we have real-time readings on these, and we feed it back to you through the HMI. So it's kind of showing here, I can look at any part of the system, low pressure, high pressure, or the oil circuit or the electrical circuit, and I would have this information immediately fed to the HMI. Very, very important. And then we get feedback through this next tool, which is the TechConnect. TechConnect is an app that we can load on the iOS platform. We can load it on the what are those other weird ones? The doggone it, why am I drawing a blank on that? Obviously, I'm an Apple guy. Oh, the Android. Yeah, on the Android. Sorry about that. But what this does for us, it gives us feedback in the palm of our hand. So now I've got machine and pump activity. I've got maintenance schedule, so I understand when I want to perform my next PM or my next maintenance on the thing. Cutting head calculator or cutting calculator, I can monitor alarms. I can get to all the links of the support sites, cutting logs, service logs, camera. All of these things are what we're going to cover in this next section. This is real-time feedback. This is the real-time feedback that makes you not have to stand there and wait. You can have this on your smart device and you can be at your favorite restaurant or at home watching your favorite show. So what we monitor, basically it lands on the dashboard and you can pick which machine. So you can have multiple machines on here, or in the case where you have us do monitoring, we could actually have multiple machines for our customers and look at it. This is more designed for shop maintenance and general managers and those type people to be able to have and access this data in real time, but not having to go out to the shop. I just think it's a real teller of the truth, right? What's going on versus what gets communicated through the staff. And immediately, one of the first landing pages on the dashboard, also, as soon as I click which machine, then it's going to show me the pressure. Is it running? Is it at high pressure? Is it low pressure? Things like that. And what we use, the scenario that we use is basically just a simple, it's a digitally fed, but analog illustrated, right? So we use a simple, red, yellow, green, or green, yellow, red, whichever way you want to look at it. So we can organize multi-machine fleets can be organized on here. but we can get a lot of detail through this app. And I'm going to just go through a few screens right now because I think this is important in bringing it all together. So you get camera views, you get the Nest view. This is what would be on the controller. You get a camera view. This is a simple USB port that you can plug a camera in, so you could watch it cutting while you're having this dinner. And or you can also have an option for the Z-axis looking down. This is a Tech Vision over the table camera. This was designed for our stone segment, right? The stone segment, you've seen this a lot. They want to do like a waterfall. So they want the edge to the seam or the vein to run over the edge, and you want to be able to match them up. So this actually allows them to look at the stone, look at the slab, and say, okay, this part of the slab is no good. This part of the slab is what we wanted to cut, and then you can set your cut lines exactly where you want them to achieve that effect that I'm talking about. So lights out, friendly, or unmanned, whichever way you want to look at it, verified from your phone, or smart device. It's just, I think it's just very, very useful tool. My truck tells me when my tires are low. My refrigerator tells me when the filter needs to be changed. We're the first to bring this to the water jet industry. It's very important to get this feedback and understand what's going on. So just a few more pages I want to show you just to really emphasize how powerful this tool is. So here I've got a pump view. It's got my high pressure output, my low pressure output, my oil service, my service, and any alarms that I might have. So again, one page, you can look at all of these things that are happening without being there. I think this is a spectacular service, general service, alarms, alarm details. You just click down. And the benefit is, tribal knowledge becomes searchable, a searchable history. So now this information gets stored within this, and now I'm able to find out, okay, how often is that happening, right? So the best hold on a second. The best practice is to track root cause and close the corrective action so patterns surface. So it's important. So now I had an event. This happened during the event. The corrective action was X. Now, if I start seeing this problem occur more frequently, now I have data point that needs a little bit more digging into, right? So I think you can see the value in that, but it's really very useful for that. And then taking it one step further, we monitor because this is important to Biesse. We monitor the environmental impact, water usage, power usage. You have a production page, so production trends, track uptime, when is it running, when it's not. So here's your calendar. We had a day off, or did somebody just not run that day? So, or was the machine down? So you can track your entire shop, or at least your water jet system. You can track the productivity that goes into this. I just think it's amazing. And then, of course, support links. You can get to our website, you can get to the parts store, and then to the service landing page as well. And then last one on this, but it is important. All your manuals, all your electrical drawings, calculate cost of job and cycle time are all on one of these tabs, right? So this whole tool you can upload and get this register it, and then you get this kind of feedback at the palm of your hands. I just think it's an amazing. It's amazing for any shop, and most shops would want it for sure. So we optimize the cutting parameters, we minimize the downtime, and with predictive features, and we reviewed the feedback through Tech Connect. Now let's talk a little bit more about the last part of our program here. Let's talk about advanced diagnostics. So advanced diagnostics is the intelligence that lives within the pump, right? So this is the smartest pump that there is in the industry, and it's just very useful. So simple human interface, where most of this communication comes through. Excuse me. The ESP advanced technology without complexity, very intuitive, easy to use. So what happens here, This is where the initial information comes through to the operator. So this will deliver like an iMessage. An iMessage, and it would be like informational. So if I'm nearing one of my high or low limits, it's going to give me that information to the operator. So he knows, okay, I got to start thinking about doing a rebuild or doing a service on this. Then that will mature to a warning. So if he ignores the information, then it'll come up to a warning. Now you're really getting close to the high-low limits. Schedule your maintenance. Now he ignores it. That happens. When you ignore it, then it goes into an e-message, and an e-message is an error message that causes a shutdown and says, I'm not going to let you do any more damage to me. You got to perform XYZ to get this thing back online. So I just think it's a very valuable tool to give you lots of stuff. This is the predictive part of it, right? So the I, the W, and the E, all predictive until you ignore it, and then it becomes basically a warning message at that point. So again, available locally on the HMI on the pump, and then we can also kick in and say, okay, through a contract, through request, whatever the case is from the service department, then we can get in through the WHMI and we can monitor these things for you. So your team can quickly troubleshoot. We can help you with that. Engineers can see trends. We can guide your team remotely through this information that we can get. And so your mean time to repair drops, and your first time fix rate climbs. Ideal situation for exactly what we're talking about here today. Just a couple more slides I really want to make clear to you. So we do have global support. We are able to log into your machine at your permission through a team viewer, that kind of thing. And the troubleshooting, the time to troubleshoot just becomes a lot faster than it would on conventional processes. Because you're not getting that feedback till you actually open them up, and you may be looking in the wrong spot to begin with. So in closing, I just want to get into the fact that all those things tied together allow us to do what we do. But sustainability is important to us. So we want to be conscious of these things. So sustainability is for us to simplify in a responsible way the production process of our customers, finding a connection between industrial innovation and environmental and social responsibility. BSA provides a way of producing that creates value not only through products, but also through the respect for people, the planet, and the future generations. So I want to just say, kind of at this point, I really appreciate everybody's time. I'm happy to answer some questions. I'd like to hear more about, if you'd like to hear more about any of our technologies, I'm sure the facilitator will be happy to provide you with the contact details. I'm always open to answering emails, questions, whatever the case is. Let's see what we've got now, Dan, and I'd be happy to answer a few.
Yeah, so if anyone has any questions, please use the question function within this interface. In the meantime, the electric servo pump, Jim, it has this ability to eliminate the dead heading that kind of you find with traditional technologies like the intensifier and direct drive pumps. What type of savings are we really talking about with that ability of the ESP?
Um, Really, it depends on how much you're running it, but the ESP cuts waste by 60 to 90%. We're really it just yeah, I mean the efficiency within the pump is going to give you very it's going to lower your operating costs significantly.
Yeah. So we had a question about a copy of the slides. This will be archived on the fabricator.com, and people will have access to it after this day. So that's where you'll be able to find it. We have another question from the audience. What is the time for it to restart after what would be a dead head? That pause and cut. What
So
type of timing are we talking about?
instantaneous. So we don't have the ramp up that you'd have, like even on a Pierce, right? On a Pierce, you would usually have a ramp up of a hydraulic intensifier and that type of thing. With the servo pump technology, we're able to do an instantaneous pierce. The thing's deadheaded at the start of the program.
Hmm. Uh, we have one. How do you control the height offset of the nozzle for unattended operation?
Ah, good question. Somebody's been playing with these things. So so initially there's two ways. We have a touch probe technology that we go and just so we lift up, go over, touch down on the material, set the standoff that way. And we also have a laser that actually will do a topographical map of the material and then adjust the standoff according to that. So it's all in the initial setup, and then you set it and forget it.
Wow. You have TechSense, you have Tech Connect. These apps kind of help with the lights out operation. Are industries actually using this lights out technology? Where are we seeing this used?
Well, lights out water jet isn't just theory, right? It's just not. It's like aerospace, automotive, job shops are running unmanned as we speak, right? So there's the aerospace industry, the automotive industries, a lot of these that have long production runs are really using this. And again, that's why I use the word unmanned. They're not running lights out at night necessarily, but unmanned means that guy can go do something else more valuable and let the water jet do what the water jet does, right? So predictive tools handle the grind, so your team can focus on more high value work. It's again, now I do have customers using this as lights out, and what I would say to anybody listening, your lights out stuff has to be your thicker stuff, right? I don't want a bunch of thin stuff because I'm going to cut
Right,
2 plates by 6 o'clock and it's pointless.
right.
But if I have a 2 inch piece that's going to cut, it's like watching paint dry. So let's get that on there at the later part of the day. Let that cut. That's I put it, and that's where you go watch the camera sitting in the restaurant. Okay.
Sounds good. We have one other one. Biesse, with its background, they obviously have an interest in sustainability. Can you elaborate on how the integration of electric servo pump technology and predictive maintenance reduces not only operating costs but also environmental impact?
Well, I think sustainability and profit go hand in hand, and the lower power use, the less abrasive we're using, the longer component life, you cut cost and carbon footprint in parallel, right? So we're producing more at a lesser cost and certainly at a lesser carbon footprint at that point.
One more from somebody that knows what they're talking about. Is there a typical seal service interval, or is it use dependent?
It really is use dependent. This has been the story of my life with water jet. It's everybody's water jet question. I will tell you this: the number one thing that impacts your component life is your water quality. So with ideal water quality, there's no telling. I've got people going 3,000 hours in between, but typical, the promise I make is, in that 500-hour range. And if it's less than that, then we need to look at, what's going on with the water. Is there heat being generated? What kind of stuff is going on that would compromise that? So ideally, you're going to get in that range, which is going to be very competitive in the industry. But
Yeah, and we have.
ideally,
Oh, sorry.
all things dialed in, excuse me, temperatures being controlled, water quality being where it's supposed to be, you're gonna get long.
Yeah, so we have one more question from that individual. Uh, I think there you go. Does the servo drive intensifier have similar seal design as uh, hydraulic intensifier?
Correct. Yep. They're very similar in design. So when you look at it, honestly, when you look at reciprocating pump technology, the hydraulic intensifier and the servo pump are very similar on the wet ends, but it's the reciprocation. How do we drive that? That makes the difference. Hydraulic intensifiers drive it through hydraulic oil pressure generated by an electric motor. So that's where the inefficiency comes from. We're generating that from an electric motor anyway, but it's not directly getting to the stroke rate at that point or to the volume output. Whereas the servo pump reciprocates and has similar seal structure or seal design and that kind of thing. That allows it to be more efficient, but because it's
Awesome.
driving directly off that motor.
Great. Well, I think that does it for questions. Thank you very much for the presentation, Jim. Learned a lot. Learned a little bit about Biesse, the electric servo uh, pump technology, and how we can go unattended with our water jet cutting. So thank you so much for your time.
I want to thank everybody for attending and everybody for hosting. So take care, everybody.
Yeah, this will be available on thefabricator.com. Just look under podcasts and you'll find it there in the next day or two. Thanks.